Alright, Title 40, Part 60, 4213. What test method the other proceed with the most if I'm an owner operating with a station combustion ignition internal combustion engine with a displacement greater than or equal to 30 liters per cylinder? 604213. What test method the other procedure must use if I'm an owner operating with a station combustion ignition internal combustion engine with a displacement greater than or equal to 30 liters per cylinder? Owner's operating stationary combustion ignition internal combustion engine with a displacement greater than or equal to 30 liters per cylinder must conduct with the performance for the test according to the paragraphs A through F of this section. A. Each performance test must be conducted according to the requirements of 60.8, Part 60.8, and under the specific conditions subpart specified in the Table 7 of the test must be conducted within 10% of the 100% peak of the highest achievable load. B. May conduct with a performance test during the periods of start, shutdown, or malfunction as specified in 60.68C. You must conduct 3 separate test runs for each performance test required in section as specified in 68F. Each test run must last at least an hour. To determine compliance with a percent reduction requirement, you must follow the requirements specified in the paragraphs D1 through 3 of this section. 1. You must use equation with the section to determine compliance with the percent reduction requirement. Concentration of the nitrous oxide particle material at the control device minus concentration of nitrous oxide particle matter of the control device outlet over concentration of nitrous oxide and particle material of the control device inlet times 100 equal to the percent reduction of nitrous oxide and particle mass emissions. 2. You must normalize nitrous oxide particle matter at the inlet and outlet with control devices with a dry base with a 15% oxygen. Use the equation of the section equivalent percent with the carbon dioxide using procedures described in paragraph D3 of this section. Calculated nitrous oxide particle mass concentration adjusted to 15% oxygen is equal to the measured concentration nitrous oxide particle mass uncorrected times 5.9 divided by 20.9 times percentages measured oxygen concentration dry base percentage. 3. If pollutant concentration are to be corrected with the 15% oxygen and carbon dioxide concentrations measured in lieu of the oxygen concentration measurement, the carbon dioxide correction factor is needed to calculate with the carbon dioxide correction factor described in paragraph D3 1 through 3 of this section. Calculate the fuel specifically in Fahrenheit value with the fuel burned during the testing values obtained from the method 19 section 5.2 of the following equation. Fuel factor based on the ratio oxygen value of the ultimate carbon dioxide volume produced by fuel at 0% excess air equal to 0.25 times ratio of the volume dry fluid gas gross calorific value of the fuel from the method 19 DSMN3 over where DSF 10.6 BTUs divided by the ratio of volume carbon dioxide produced with the gross calorific value of the fuel method 19 DCM3 to the third DSCF 10 to 6 BTUs. Alright, 2. Calculate the carbon dioxide correction factor correction measure data at 15% of the oxygen is followed with correction carbon dioxide correction factor percent is equal to 5.9 over FA. 3. Calculate the nitrous oxide particle matter with the gas concentration of just 15% oxygen using carbon dioxide as follows. The calculated nitrous oxide particle material correction adjusted with 15% oxygen is equal to measured concentration nitrous oxide particle mass uncalculated over times X times the carbon dioxide times divided by the percent measured concentration of CO2 dry base percentage. To determine the compliance with the nitrous oxide mass per unit out of the emission limitation, convert to the concentration nitrous oxide engine exhaust using equation 7. Air emission rate in grams per kilowatt hour is equal to measured nitrous oxide contraction parts per million times 1.91 times 2 times 10 to the third times the stacked gas volume flow rate in standard cubic meter per hour times the time of the test run in hours over kilowatt hours. Brake work over the engine in kilowatt hours. Alright, to determine the component with the particle mass per unit output of the emission limitation, convert to the concentration particle mass of the engine exhaust using the equation 8 of the section. Emission rate in grams per kilowatt hours equal to calculated mass concentration grams per standard cubic meter times stat gas volumetric rate of the standard cubic meter per hour times time of the test run in hours over kilowatt an hour minus hour engine output engine in kilowatt hour. Alright, that was 604213. What testament other procedures must I use with the owner and operator stationary combustion ignition internal combustion engine with a displacement with greater than equal to 230 liters per cylinder?